So this problem states that partition array into two arrays to minimize some difference. We are given an integer array nums of length 2 plus an integer. We need to partition into two arrays of length n to minimize the absolute sum difference, and put each element of num in one of the two arrays, and we need to return the minimum possible absolute difference. So they have given one example 3973. So they were dividing into two parts, exactly two parts, and this is the least minimum we are expecting. So let's understand this problem. What we are given one array 3, suppose that array is 3973, and we need to divide this array into two parts, basically two subsets. Two subsets we need to divide this. A subset 1 and another is subset 2. We need to divide this. So what are the possible subsets? And one more important thing, these subsets should contain equal number of elements. These subsets should contain equal number of elements. Contain equal number of elements. Equal number of elements. That's what they have given. That's what's asked in problem. So if we say S1 is one subset, so we can divide with something like this 3, 9, 3, 9, and another subset can be corresponding, another subset can be 7, 3. Another possibility can be we can divide something like this 3, 7. Another possibility can be we can divide something like this 3, 7 we have already taken, and we should take 9, 3. Another we can take like this here, so we can take like 3, 3, and we can here we can take like something like 9, 7. Right. So if we see this sum, it will be 12, and this sum will be 10. And if we find the absolute difference, like basically what they're asking the absolute difference. Right. So we will get something like with ABS of 12 minus 10 will be equal to 2 here. And if we check it here, we will get something like ABS of 10 minus 12 is equal to 2, because they're asking absolute difference. And here we will get 6 minus something like 9, 7, 16, we will get something like 10. So as you can see here, this is the part where we get the minimum difference, right? This is where we get the minimum difference. So if we see here, two things we need to keep in mind while making a subset. Both subsets should contain equal number. That is one important constraint that will help us in our future computation. That will actually simplify our future computation. So in this problem, can we write something, since we need to divide the two subsets? Usually in these kinds of problems, what we need to do mostly, like most of the cases, we need to actually can we form one subset, because it's much more easier to put element in one set rather than in two set, right? Like it feel like easier to us. So same mathematical approach can we try here. So if we see here, S1 plus S2 equal to total sum, right? That will always be true, right? So if we see here 12 plus 10, 22, here also 22, here also 22. So this will always be true irrespective of what we take. So as it's told, we need to find the minimum of absolute of subset sum 1 minus subset sum 2, right? This what we are asking. So can we replace something with sum 2, like this? We can write something like this: S2 equal to total sum minus S1, right? We can write it like this. This part can be written like this. If we want to write it, it is something like 2 into, if we summarize this like sum1 minus, and if we say sum2, so sum2 is total sum minus s1, right? We can write it. We can write it down. So what we will get, if we will get at the end, minimum of ABS 2 into 2 into sum1 minus total sum. At then we will get this part. Right. So we can see this we got. So if we move this here, like so as we have derived now, we have got something like this. We need to find the minimum of absolute of 2 into s1 minus 1, right? This we have derived. Now we have moved to one set. Now we need only one set. We have moved from, and this set should contain n number of elements, like that what we have discussed earlier. So s1 should contain have n elements, or we can say total length of main array by 2. Right. So move this here, here, here. S1 should have n elements, or total length should be, or I mean it should contain half of the element of the main array. So now our problem became much easier. We need to create one subset that contain n elements, right? Now if we want to minimize this part, minimum of ABS 2 into this part, if we want to minimize this part, so what would be our S1? Then only we can minimize this. So if we say S1 should be as close to total sum by 2, right? Then only we can minimize this, right? Let's suppose what I'm saying here, let's suppose total sum, suppose we get something like 10. So sum by 2 will be 5, right? And we want minimum of ABS 2 into subset sum 1 minus sum. We need to minimize this part. So let's suppose S1 came 9 for one of our subset. Again, second part S1 came like around something like 4. Second part S2 came something around 5. Again, our S1 came something like, if we see here, S1 came 5, and we will take one more value, S1 came 8. So for this, what will be this value? 2 into S1, it will be like 2 into S1, 18 minus sum minus 10, it will be 8, right? So now this, what will be S1? 2 into 4, 8 minus some, since it's absolute, so 2. This will come 2. Now what will come? This 10. So this will come 0. And what will be this? It's 16. 16 minus some, 6. So as we can see, as we move closer to 5, 5 is what? So 5 is basically 10 by 2, right? Which is total sum by 2. So our this part became minimized. This part became minimum, right? So we can say that we need S1 as close to sum by 2, right? Now we need to generate all subset sum whose sum will be equal to sum by 2 or not. Actually, what we are generating all the subset sum. Then only we can check whether whether their sum is close to sum by 2, or whether their sum is not close to sum by 2, or whether it is equal to sum by 2. Right. So we need to generate all the subset here. Now the problem is, suppose in original array, the main array which we are considering, the number of elements in that array is n. So S1 we need to choose exactly half, right? N by 2 we will choose. That's what we have discussed. So how much number of elements will be there? How much subsets we need to generate like this? Suppose let's give one example. N is around 30 and this comes 15. So total number of subset will be something like around N C. Okay, this is what the formula is. So if we do something like 30 C 15, so it will be something around what I have calculated. It will be something around 155 million, something like this, which is a huge, like this much subset we need to generate, right? So better what we can do is much better approach. What we can do is we can divide this whole array, the main array, what we have done. For example, the own array was, if we look 3973, it was so sorry. So the array was 3, 9, 7, 3. If we divide this into 2 equal halves and we generate their subsets separately, 2 equal halves, what I mean, array 1 will contain half of the elements, like 3, 9. Array 2 will contain half of the elements, 7, 3. And we will generate their subsets separately. These subsets we will generate separately, then our operation will much reduce. Let's see in this case how this happens. Suppose this was our main array, and now if we have divided into 2 halves, so array original contained like around 30. Now array 1 will contain around 15, and array 2 will contain around 15. Sorry, array 2 will contain around 15 elements, right? Now we need to generate the subset of all these 15 elements at one time and all these 15 elements at one time. So how much possible combination will be possible? It will be like around 2 to the power 15, right? That is the formula. 2 to the power 15 is the actual formula. 2 to the power 15 for this much number of combinations will be needed for both array 1 and array 2, right? Which is equal to around something like 32768. So obviously this is much lesser than this million subset generator, right? Very less than if you compare to around 155 million. So So keeping this in mind, we will divide our main array. Suppose the main array was in our case 3973 sorry, comma will be there. We will divide this into two halves. 39 the main array was, and we will divide into two halves. So array 1 will contain first half 3 comma 9, and array 2 will contain exactly second half elements 3973. Right. Now if we look at the problem, we need to generate the subset, right? Subset sum. That what we are looking for. How to generate and how to generate it efficiently. In case we have large number of records, in case we have large number of values. So what we will do, we will suppose for array 1 we will generate all the subsets possible. First suppose array 1, if we say all the subsets are possible are, if we can see 3 is one subset, 9 is another subset, and if we go like 3 comma 9 is other subset, right? These are all the subsets possible. And if we go to array 2, what are all the subsets possible? Same 7, and also one subset is null, like we like didn't pick anything. That is also one of the subset. 7, 3, and other will be we picked all both the elements, and other will be null. Right. These are all the subsets possible. Right. For this. Right. So if we see here, and what will be their corresponding sum if we look, because we are looking for sum, right? The subset sum. So we can say the sum will be 3 comma 9, and this will be 10, and this will be 0. If you look to this, the subset sum will be 7 comma 3 comma 10, and there will be 0. So these are the subset sum. Now one more thing you need to keep in mind, as what we are doing, we are dividing the main array into two halves, right? Left half and right half. Basically left half and right half, we are dividing the main array. We are dividing this into two halves, right half and left half. So, and also our subset sum that we are trying to make, subset, it should contain L number of elements, right? And this only we are dividing. This is what this subset sum is basically this only, like this only we are dividing to two half, left half and right half. That what we have discussed. Because if we like the if we take from the main array, then the operation will be too complex, so we are dividing the two half. So total number of elements should be n elements. Now we will write one method that will give us all the subset sum for both left half and right half along with their count. By count I means the number of elements responsible to make the subset sum. Let's suppose here if you look array 1, so the number of elements responsible for 0, I mean if we take like if you have taken no elements, then the corresponding subset sum is 0. Okay. And if we have taken only one element, then what we got 3 comma 9, right? And if we have taken all the two elements, then we have got 10. This is for left half. And similarly we can, for right half also we can do, for right half also we can do, none we have chosen, no element, then this will be something like this. And And if we have taken one element, then our corresponding subset sum are 7, 3. And if we have taken two elements, our corresponding subset sum is 10 in this case, right? Now our method will return something like this: the count and the corresponding subset sum formed. So obviously, like many of us would normally think of hash map or some to in like integer like will also work. Integer array will also work. Something like that will also work. Okay. So what I'm trying to say here is we can put this in an index array, all this count, and this will be our 0th length, this will be 1, this will be 2. So this 0th part will contain 0, this 1 will contain 3, 9 in a list. This will be in a list. Then 2 will contain something like 10. Like this, you will return something like this. Now here S1 is what? S1 is basically left half sum plus the right half sum, right? This is what S1 is. And number of elements, S1 has n elements. Then in that case also the left count, I mean the number of element left should have, it should be equal to number of element right should have, right? That we need to take as we have discussed. And also we are tracking both here. We are tracking the subset sum along with the count also. I mean counting the number of elements required to make that particular subset sum. Here we are tracking here both. So suppose we come a scenario if we have taken left sum, left count, left sum we have taken, suppose 3 here. Then what will the corresponding right sum we need to take? And right sum we will look into the right half of the array, right half, right? We will always look here. So as we have discussed, sum 1 should be as close to sum by 2, right? So can we say left sum plus right sum should also be equal to sum by 2. So right sum, we need to look for something sum by 2, right? We need to look for as close to the in right half, right? And also one more thing, again count. For example, left sum we have taken k elements, or we can say one element. Then in the right count we need to take how much? Exactly n minus 1. Then only this both will be equal to n count, right? Because we want S1 should contain exactly an element. So if the left count is 1, then right count should be n minus 1. So here we have one very good advantage. We did not need to look to every count in the right half, like in the Here we don't need to look into the like the zeroth count, one count, or two count. We can directly find which right count we need to look for. Right. So this is one good advantage we have here. So now what we have got that particular list where we need to look for the right sum. Right. Now our problem boiled down to something like we are given a list we are given, and we need to search a value or something as close to that value, right, in that list. So we are actually what we are looking at, we are looking for right sum in this list, and this list we got with the help of this, right? So we got something like right half, and we are going to look for n minus 1. Like if we generalize this, so let's suppose we generalize this part. Suppose from left the count we have taken is k. Actually, the sum what we are looking that belong to k count in this part. So corresponding right count will be n minus k. That's what we need to look for. So we got one list, so we will get one right list from here, from our right half, which will be n minus 2. Here we will get something like this. Now we got one list, and our what we need to look for, we need to look for right sum, right, that we have calculated earlier, which is equal to total sum by 2 minus left sum. So we got one list, we got one value to look for. So this is basically binary search, right? For example, if we suppose like if we go for brute force approach and we search for some element in a list, then complexity will be O of n, right? But we can simplify this using binary search approach. So we will sort this list, sort this right list, and we need to look for right sum in right list, that element or something close to that. So isn't it we are looking for a lower bound here? What is lower bound? Element that is greater than or equal to the target, right? Here our target is right sum. Since it's possible that right sum can lie or cannot lie, right? So we need to look for something close to it. So lower bound will give us the value which is close to this. Now there is a possibility, for example, as we have told, we are looking for something close to that particular target. Let's suppose we are looking for right sum 8, and our list in which we are looking for something like 4, 5, 7, 12, 13, and 14. This is our right list. So lower bound will give us index, right? So our method lower bound will give us something like, if we look what it will give us 0, 1, 2, 3, 12, because 12 is the element that is greater than or equal to 8. But it may possible that this idx minus 1 can also be closer to that 8, right? Because if you look at the insertion point here, insertion point lie here, right? 8 lie here. So it may possible that this will be closer and this can be closer. Both can be closer, right? Both possibility we have. And from both we can get our minimum. So we will look in both idx and idx minus 1. Condition should be, we need to keep in mind, if idx should be greater than 0, only then idx minus 1 is possible, right? And idx is possible if idx is less than total size of that array, right? Otherwise it's not possible. So these two conditions we need to keep in mind before going for idx and idx minus 1, otherwise we will get a out of bound exception. So we will calculate our sum with these two. We got left sum and we got corresponding right sum, something that is close to that right sum, right? We got, and this right sum we got from idx. This is what we got from idx. This is sum, total sum. One min we will get from here, and another min we will get from this part, left sum plus right sum, idx minus 1, total sum. So these are the two, and the minimum of all these possible values will be our answer. So this is the whole algorithm for this. Now let's back to the coding part. So if we see here, we are calculating the total length. Total length is nums dot length, and it's obviously n by 2. Total sum we are calculating, and target is basically sum by 2. Here if we look, this is the target, or this is the target, like sum. So this is sum by 2. This is not the target. Now as we know, we need to, which will have a list at each index. So basically we are just like performing those only. And now we are generating the subset sum. Basically we are filling this. So for this we have a method here, generate subset sum. So like normally when we generate the subset sum, what we will do, we will just have, like for each number we have an option to like whether to take it or to not take it. That's how the subsets are generated, and the similar way we will also generate a subset sum. So this option is for not take. We will not take that number. We will move the start from 1. Since we have not taken, count is basically for tracking the number of elements till now, because we want the length of that subset sum also, right? I mean the number of elements like required to make that particular subset sum. So for that only we have taken the count, and cut sum will give us the track of the current sum. And if we have taken that element, then we will increase the count by 1, and also the subset sum will also increase. Once we have reached the end, we will just add to that particular index that current sum, and we will like return from it. Yeah. This method is just for calculating the lower bound. As we have discussed, we are just calculating a lower bound from here. Now what we will get one left and we will get one right. So we will iterate the left array. Left length is basically this only, what we have discussed. When where is given, this is the I, this is what I is 0, I mean the left count, and this is the corresponding right count. So we are finding the left length, and corresponding right length will be n minus I, as we have discussed. Both should contain n elements. If we combine this, then it should contain n elements. Now we are finding the corresponding subset sum generated from these number of elements. So for left we will get one list, and for right we will get another list. Since we need to apply binary search, so we are pre-sorting this subset sum right corresponding. Now we will iterate one by one all the subset sum of left. We will get the corresponding right sum by target minus left half. We will find the lower bound we have discussed earlier, and these two conditions at the last that we have discussed. We are just finding the left sum, the subset sum dot right, and we are minimizing these. Also we are checking for index minus 1, as we have discussed earlier, because of that because here what we have discussed here. So without code.